Hello everyone. Today I am going to solve one questions of partial differential equations which were already solved in last video, but I will solve partial differential equations by Lagrange method. So first of all, you have to know about the Lagrange method and their equations. First of all, Lagrange method has some form, and the form is this. First you see the form. Form says that we have capital P, small p, capital Q, small q is equal to R, right? First of all, you have to, this is the standard form. This is the standard form of Lagrange. If your equations is in this form, if your equations is not in this form, then you have to try to convert the in this form. The thing is that you have to do anything, do some change, and you have to convert your expression in this form. I hope you understand very well. Then after, you see here x plus 2y. If you see there, x plus 2 is capital P, 2y capital Q, and R is equal to 2z. We can write as like. So here we write let P is equal to x plus 2 and Q is equal to basically 2y and R is equal to 2z. I hope this is clear to all. Now, the Lagrange method says that del x by capital P is equal to del y by capital Q is equal to del z by capital R, right? In this way, the Lagrange method and the equations can be write in this way. After resolving this standard form, then you have to go through this step and let this is equations 1. You can assume equations 2, equations 3 as well. Now take two equations at a single time. Firstly, I see equations 1 and equations 2 and integrate both sides now. So let dx by p is equal to dy by capital Q. Integrating both sides, what we observe? This is very simple integration, right? The integration is standard form, as we all know the integrations of 1 by p. But of course, we do not write the p, because I have assumed what is the value of p. P is equal to x plus 2. So we have to write x plus 2, because integrations, when we integrate anything with same variable, so we write del x by x plus 2 is equal to del y by 2y. Now you see, this is the very simple standard form of integration, and I hope you all know the integration is log mod x plus 2, and there 1 by 2 is constant, so we can outside the constant and we get log y. Both sides having log, so we assume constant log c1. Now if you this log y, if we remove here, then we can write as in this way: log x plus 2 minus 1 by 2 log y is equal to log cy. I hope you understand. Now this is here is the property we will use, log a minus log b. But from this, before this, first I know the property of logarithm. Property is that if you have constant, if you have we can write here a log b, so we write now log b to the power a. right? The same logic we will use here. So what we write? We write log x plus 2 minus log y 1 by 2 and log c1 as it is. Now log a minus log b, as we also know the property is log a by b, so we directly write log a by b. And you know y to the power 1 by 2 is root, under root y we can write. So I directly write these things, log x plus 2 by root y is equal to log c1, right? Things is very clear. Now log we can cancel out, and at the end we get x plus 2 by y is equal to c1. This is your first constant, first c1. And now we will solve c2. For c2 we take equations 2 and 3. So start. Now solving 2 and 3. Solve 2 and 3. What we have? We have dy by 1 by 2y and this tz by 2z. Simple. 1 by 2 outside, then we get dy by y. 1 by 2 outside, dz by z. Simple integrations we have to do. Then we do 1 by 2 log y and 1 by 2 log z we can write. Okay, now simply we cancel out and we get log y is equal to log z. Both side log, then you can cancel out. Sorry, yes, you have to take another constant, that is log c2. Log c2. Now log y minus log z. Here is also property we can use, log a plus log b, that is we will use log z c2. Now log cancel, c2 is equal to y by z, and this is your c2. And your general equations would be, let u is equal to x plus 2 by root y and v is equal to y by z, and general equations are in f u v is equal to 0 and f is equal to x plus 2 by root y, and using v the value of this y by z. This is your required general equations of the partial differential equations. I hope you understand very well, because the concept, there is one thing is new, is Lagrange method. Otherwise nothing I use new. All are basic of your intermediate. I hope you understand very well. See you later. Thank you.